4 board, the tiles spawning in after every move you make. And when you make a move, it shifts the tiles to whatever side of the board you make the move towards. And similar tiles combine to double their value into a single tile. And when the board fills up with tiles, since they spawn in and return, your game is over and you're stuck with the score that you got. So combined with my like for this game and my passion for computer science and coding, I decided I would try to make a simulator for the game and develop algorithms that can play the game on its own, with the goal of achieving the highest score possible. And over the period of this project, I simulated the game, of course, and I made a total of 12 algorithms to play the game. I started off making these blind algorithms. They never looked at the board. They just made a set of moves, or a set of random moves. They performed quite poorly. It was just to see how well they could do and see the limits of the blind algorithms. Then after that, I started using 3 kind of thought processes to play the game. The first of the 3 was to make the move that gained you the most points immediately, just to, using just the points as a motivator. And then the second way that it would look at the game is to see how many spaces you would clear after every move, just to keep the board clear with the goal of not ending the game. And the third one that I use, I like to call flow. And that's kind of a term that I made. I call a board with a high amount of flow when the higher tiles are concentrated towards the corners of the board, so it would have some order to it, and hopefully it would stay more organized and free so that the board wouldn't fill up as fast. And the last 4 algorithms I actually made it so it looked past just a single move into the future to hopefully make 2 or more moves into the future to see more possibilities of high point moves and spaces cleared and flow increase. And the average score of my best algorithm ended up being about 14,000. And you might look at that and say, like, wow, I've done better than that on my own. And I have too, but that only shows there's a lot of room for improvement for this. And I can continue to make better and better algorithms and improve it. And what was peculiar, though, is because the 14,000 came from only looking 2 moves into the future. And as you look more than 2 moves into the future, obviously the time efficiency is increased a lot. It takes forever when you look 3 or 4 moves into the future. But the reason why I don't think it scored as high when you look 2 moves into the future is because my algorithm didn't take into account these random tiles spawning, which is a really important part. So that if it saw a big point move 3 or 4 moves in the future, say 2 or 3 moves into making that big point move, a tile would spawn into the way, and then it would just totally destroy all the progress you had, leading into a lower average score. And so that also just sort of shows how much room there is for improvement. This is the basic program structure. I wrote this in Java using BlueJ development environment simply because I have some experience with it. It could have been made in any other Java development program. And the game driver class is a class that's used to simulate n number of games. I used 1,000 for all the trials in my data. And it also collects the data, the average score, median score, standard deviation, some of the highest and lowest point boards. And it presented this in just a text format. There wasn't any GUI. It's kind of hard to look at. The manual game driver and the test game driver, there were temporary classes that were removed at the end of the project. The manual game driver was used to test the text board class, which I'll tell you about in a minute, to make sure that it was accurate to the actual 24 game. And the test game driver was simply used instead of the game driver to test the algorithms that I did develop, so that I didn't have to ruin the game driver class. The text board class was the largest part of the project. It held all the data and methods necessary to play the game 24 games. And so it could scan the board, it keeps track of all the tiles, and it just manipulates, it has all the manipulating abilities to look at the board. And I call them AIs, there's just a short term, and I had 1 through 12, and I just kind of simplified it right there. And those had the ability to access all of text board's data and methods. So it was really, really reusable because a thing in Java you can inherit from a different class, and the arrows kind of represent the hierarchy of the class. So the algorithms inherit from text board, which allows you to not have to have all the text and the code in text board in each of the classes. So it made this really, really easy and cool to use because I could just add a new algorithm class right now, enter a couple of keywords in the game driver class and in my class, and I can just test it immediately. It made it very reusable and easy to add on to if you were a programmer. And to show you which lines of text that you can change, the one highlighted right up at the top, the extends text board, that just shows that it inherits from the text board class. And you instantly have access to all the public methods. So it's really reusable. And this is a screenshot from the game driver class. That line towards the top was also highlighted. That just instantiates the new algorithm to be used. So you just change whatever you name your algorithm, you just change a couple numbers there, and you're instantly ready to go where you can just test it. And the reason why I like this so much is I thought it could be really cool to be used in a lab environment for AP Computer Science. I'm taking AP Computer Science this year, and I've had some really boring labs to do. I think it'd be really fun if you can incorporate a game and just making it really open-ended. Just tell your students to make a method in the game and get the highest score possible. I think that'd be really fun, and it would also teach a lot of core concepts that are necessary to take the AP Computer Science test, such as manipulating two-dimensional arrays. There's always a question on the AP test for that, from my experience from some of the practice tests. So how does this relate to anything past just being a fun game? I found two higher concepts that I found that could be related to this. One is game theory, and the other one would be agent-based modeling. The reason why I say game theory is because even if it is a one-player game, the computer kind of makes its own moves anyway, spawning in the random tiles. And game theory has to do with looking at your possible moves and your opponent's moves to make the one that's more in your favor, or the most in your favor. So this has a lot to do with it because it's looking for the best possible move you can to gain the most points and to get the highest score at the end. And I think this has to do a lot with agent-based modeling because one can think of the tiles on a 4x4 board as just an agent in this project or a game. And I think that it would follow just about three rules. Is one, it takes up a 1x1 spot in the grid. Each tile does. Two, it can combine with a similar tile to double its value in each singular tile. And three, it cannot combine with any dissimilar tiles and they are stuck in their 1x1 slot. So just using those three rules, you can kind of think about it logically. It's just instead of a single game, just a lot of agents or tiles that can interact with each other. And this is what the output of the program looks like. I didn't have a GUI, I didn't develop that for the program. It was kind of very text-based, and when I was testing it, it's kind of hard to look at for too long. It's flashing text on the screen all the time. And as you can see, it presents the lowest score, the lowest scoring board, the highest score, the highest scoring board. And this was a trial of 1,000 trials for the last algorithm I made, 12. And so, in conclusion, thank you for Dr. Barry Ferris for informing me of this meeting and giving me some support to submit my paper to this. And thank you to the Junior Academy of Science for giving me the opportunity to present today. Questions?
Sorry.
Yes.
That was the highest score we got,
Yes.
right? I never played the game yet. Is this going to be the only play the highest score is? Or
Yes.
how would you change your algorithm to have the least amount of time to play with the highest score? Is there a way to do that?
Right.
Incentives to get score?
What I try to do is, well, in game theory, they tend to use recursion a lot, and they're looking for these trees of possible moves. And I did it iteratively. I'm very new to recursion. I've only taken it in computer science this year. And recursion would have actually, it's very inefficient, but it really did the job probably the best. It makes a really elegant solution to the problem. But what I would do is I would try to find an iterative solution for just using 4 loops instead of calling them honestly. And just basically improve my programming experience really because I'm only self-taught in AP Computer Science this year. So I could probably improve the program design, make it more easy to use in a lab environment as well as increase its time efficiency.
Yeah, because time efficiency would be, in my opinion, key.
Yes. I consider that like kind of learning the game as it goes along. I did consider that mid-development, but I went more with this just because it seemed more kind of straightforward, but I did consider that.
You stated initially